Far above us, beyond the reach of any telescope in a backyard or any city light, a slow-motion disaster is unfolding. Not a fire, not an explosion, but a cosmic ballet so grand in scale, so immense in consequence, that it will one day reshape the very fabric of our night sky. A collision is coming. One so vast and so inevitable that no force in the universe can stop it. The Milky Way, our home galaxy, is on a collision course with its massive neighbor, Andromeda. At first glance, it sounds catastrophic. When we hear the word collision, we think of impact, destruction, and finality. But in space, things are different. Galaxies are mostly empty. The stars within them are separated by such immense distances that even when galaxies crash into each other, the stars themselves almost never collide. Instead, they dance. They warp and twist. They merge and rebirth. In this case, the result will be nothing less than the transformation of everything we know about the structure of our galactic home. The story of this future collision begins with motion, silent, invisible, but ceaseless. Everything in the universe is moving. Andromeda, the closest spiral galaxy to us, is currently about 2.5 million light-years away. But that distance is shrinking. Every second, Andromeda gets about 110 kilometers closer to us. That may not sound like much, but over the span of millions of years, that's a headlong rush. Based on the latest measurements from the Hubble Space Telescope, Andromeda will collide with the Milky Way in approximately 4 billion years. This isn't a theory born of wild speculation, it's grounded in data. Astronomers have precisely tracked the Doppler shifts in the light coming from Andromeda, allowing them to measure its velocity. Combined with proper motion studies, we now understand its trajectory well enough to model the future. What they've found is both astonishing and inevitable. Our two galaxies will interpenetrate, merge, and eventually settle into a new form, a single, massive, elliptical galaxy. But what will that process look like, and what does it mean for Earth, for the Sun, and for the billions of stars caught in this slow-moving drama? As the two galaxies approach one another, gravitational forces will begin to tug and twist their structures. Spiral arms, those elegant pinwheeling streams of stars and dust, will begin to warp. As the outer edges touch first, a gravitational frenzy will ensue. Tidal forces will slingshot stars out of their orbits. Clouds of gas will be compressed, igniting furious bursts of new star formation. These cosmic fireworks will light up the night skies of any worlds still orbiting in peace. When Andromeda and the Milky Way first meet, it won't be a single, clean pass. It will be a chaotic dance with multiple approaches and retreats, stretching over billions of years. The first close pass will rip both galaxies apart in terms of structure, drawing out long tidal tails of stars and gas, ribbons of light stretching across intergalactic space. These are the fingerprints of cosmic interaction, and we see them in other colliding galaxies across the universe. Eventually, after perhaps 2 or 3 such encounters, the cores of the Milky Way and Andromeda will spiral into each other. Supermassive black holes, each sitting at the center of their respective galaxies, will begin their own gravitational tug-of-war. Over time, they too will merge, unleashing gravitational waves across space-time. This cataclysmic union of black holes will briefly outshine every star in the combined galaxy, not in visible light, but in the ripples they send through the fabric of the cosmos. The resulting galaxy will no longer resemble the graceful spirals we see today. Instead, it will likely become an elliptical galaxy, more like a 3-dimensional cloud of stars, rounder, puffier, and older. Astronomers have already coined a name for this future hybrid, Milkomeda. From our perspective here on Earth, assuming Earth still exists, the night sky will change dramatically. Today, when we look up, Andromeda is a faint smudge, visible only from dark sky locations. In a billion years, it will dominate the sky, growing larger and brighter. Eventually, it will fill the heavens with a glowing arc of stars as the galaxies entangle. If humans or our descendants are still around to witness it, they'll see a universe very different from ours. Constellations will dissolve as stars are flung into new positions. The familiar patterns of Orion, Ursa Major, and Cassiopeia will vanish. In their place, a chaotic new sky, brighter, more crowded, and forever shifting, will take shape. But what about the Sun and Earth? Will we survive? Ironically, despite the scale of this cosmic confrontation, the odds of a direct star-to-star collision are extremely low. Space, after all, is mostly empty. The average distance between stars in our galaxy is about 5 light-years. Even during the height of the collision, most stars will simply pass by one another. The Sun will likely survive the encounter intact, but its orbit will be altered. It may be thrown into a different region of the new galaxy, perhaps closer to the center, or perhaps flung farther out. Earth, if it remains habitable, could see its position in the cosmos radically shifted. There is, however, a more pressing issue: time. Long before the collision concludes, the Sun will have reached the end of its main sequence life. About 5 billion years from now, the Sun will exhaust the hydrogen in its core and expand into a red giant. It will engulf Mercury and Venus. Earth may or may not be consumed, depending on the extent of the expansion. Even if it survives, it will be scorched and sterilized, its oceans boiled away, its atmosphere stripped. Life as we know it will no longer be possible. So, while the galactic merger will be a spectacular transformation, Earth won't be a habitable witness to its finale. Still, our legacy might be carried on. Perhaps humans will have colonized other star systems by then. Perhaps artificial intelligence or other forms of life we've yet to imagine will look up at the sky of Milkomeda and wonder how it all began. This kind of galactic merger isn't unique to us. In fact, it's quite common in the universe. We see galaxies colliding everywhere we look, sometimes producing stunning shapes like the antennae galaxies or the tadpole galaxy. These interactions play a crucial role in the evolution of galaxies. They trigger starbursts, grow supermassive black holes, and redistribute angular momentum. In fact, many of the elliptical galaxies we observe today are believed to be the remnants of past mergers. It's part of a natural life cycle, a dynamic process that transforms order into chaos, and chaos into a new kind of order. So why do galaxies collide? The universe is expanding, isn't it? Shouldn't everything be moving away from everything else? Yes and no. The universe is expanding and distant galaxies are indeed receding from us. But on local scales, where gravitational forces dominate over the expansion of space, objects can and do move toward each other. The Milky Way and Andromeda are gravitationally bound. Their mutual attraction overcomes the expansion of the universe between them. This means that while most galaxies are drifting apart, these two giants are destined to meet. New simulations now suggest that smaller galaxies, like the Triangulum galaxy, another neighbor, may also be involved in this merger. It might collide with Andromeda first, or be pulled into the gravitational mess afterward. The result could be a triple merger, leading to an even more complex and massive final structure. But beyond the technical details, there's a deeper, more philosophical question. What does this mean for us, for our place in the cosmos? It's a humbling reminder. Galaxies, stars, and even planets are temporary. Structures rise and fall. Nothing is fixed. The cosmos is not a static backdrop. It's alive with movement, with growth and decay on unimaginable timescales. In the grand scheme of things, our civilization, our history, even our species are tiny sparks in the darkness. And yet here we are, able to look up, able to calculate the trajectories of galaxies billions of years in the future, able to predict their fates. The fact that we know this is happening, that we can simulate it, understand it, and prepare for it, even if only intellectually, is a triumph of human curiosity. We are witnesses to a future that none of us will see, but that we can already comprehend. And in that knowledge lies a kind of immortality. We may not survive to see Milkomeda rise, but we've already written its story. We've placed ourselves into the future of the cosmos by daring to imagine it. In the end, when galaxies collide, it's not the destruction that matters most, it's the transformation. From two spirals, something new is born, something bigger, something more complex, a universe forever in motion. This is not an end, it's a new beginning. And the proof? It's all around us. We see it in telescopic images of distant galaxies mid-collision. We measure it in the redshifts and blue shifts of stars. We simulate it with the laws of gravity and motion. We see galaxies merging now in the present. And we know without a doubt that ours will join them. Not today, not tomorrow, but someday, long after the last human breath is drawn, long after the last tree has withered, and long after the last footprint on Earth has been erased by time, the sky will change, the galaxies will embrace. And in that moment, the universe will write a new chapter, one that began with us looking up and ends with us among the stars. Thank you for taking the time to explore the universe with us. We hope this knowledge brings a new light to the way we see life and the cosmos. If you found this video helpful or inspiring, we invite you to share it, leave a comment, and join us on the next journey. Until then, keep asking questions because curiosity is the beginning of all discovery.